All right, so as promised, here's the video to add to what we did in class today with graphs of sine and cosine functions. So we had a long discussion today about the basic graph of sine of x. We talked about those 5 key points, that the graph of sine of x starts at the 0, it goes up to its max, down to its 0, down to its minimum, and then back to the 0. And that's a full cycle for sine of x. We know that that full cycle is completed with a period of 2 pi, so that's the distance across the x-axis where that happens. And we got all of those values off of the unit circle, okay? So I want to talk now about graphing the graph of 3 times sine of x. So what you're going to notice here are some of the changes that happen to the graph. So let's get our graph drawn here. My x and my y-axis. Remember that my x-axis, we're kind of trying to shift our thinking. We're no longer counting our x's by ones, but now we're counting it by pi over 2. So it's pi over 2, pi, 3 pi over 2, and 2 pi. So take a look here. All I'm doing, I have my basic function sine of x, and I'm just multiplying it by 3. So let's think about those key points that we did for the original graph. The first one was sine of 0. So when I plug 0 into my function, looking at the unit circle here at 0, sine is the y, so that's equal to 0. If I multiply that by 3, then 3 times 0 is still just 0. So my first key point is there at 0. The next one then is sine of pi over 2. On my unit circle, I go to pi over 2. Sine is the y, so that's equal to 1. And for this function here, remember we're multiplying that by 3, so we're just taking that value and we're multiplying it by 3. So now instead of that maximum being at 1, my maximum is now up here at 3. I do the same thing for my next point, so sine of pi is equal to 0. When I multiply 0 by 3, I still get 0. So my midline, you'll notice, those zeros are still the same because it doesn't matter when I'm multiplying by, it's still going to be a 0. The next key point is sine of 3 pi over 2. I go to 3 pi over 2 on my unit circle. Sine is the y, so that's negative 1. And I'm multiplying that output there by 3. And so that's going to go down to negative 3. 1, 2, 3. Then the final point there, sine of 2 pi is equal to 0. That gets multiplied by 3. And so that's still at 0. So what you'll notice about this graph is that it's taller, right? Like it's stretched out a little bit, but it's still the same shape. It still has the same period. The only difference is that your range now has changed from negative 1 to 1 to now your range is negative 3 to 3. So having that number in the front is going to change your range, and it's going to make your graph stretch out and look a little bit taller. The next one I want to talk about is the graph of negative sine of x. Let's use the same approach here for how we just did it with the 3. Okay, but now we're multiplying by a negative instead of multiplying by a 3. And so again, our graph is counting by pi over 2, so pi over 2, pi, 3 pi over 2, and 2 pi. And I'm going to test all of those key points. So sine of 0 is equal to 0. If I make that a negative, it's still a 0. The next one, sine of pi over 2 is equal to 1. If I make that a negative, then now I'm going down to my minimum at negative 1. So kind of start to think about how this graph is going to look. Sine of pi is equal to 0, so when I multiply that by a negative, it's still just a 0. Sine of 3 pi over 2 is equal to negative 1, and so if I multiply that by a negative, now it's going to be a positive 1. And then sine of 2 pi is equal to 0, and if I multiply that by a negative, it's still a 0. So take a look at what this graph looks like. We've got a very similar shape. It's still that wave. That wave is still going to continue. But if you think back to what that original graph looked like, the original graph, let me change my color here so it's not confusing. the original graph went up to 1, then to its midline, and down to its minimum. So all we've done by putting that negative in the front is we've flipped it over the x-axis, and that's the type of transformation we expect to see anyways. So this hasn't changed at all how transformations work with a graph. The same thing is true. Oh, let me also just state that just by putting a negative there, that doesn't change anything about your range. Your range is still from -1 to 0. All right, there was a little interruption there with the doorbell ringing. Sorry about that. So as I was stating, the range doesn't change by putting a negative in the front. We can still see that the minimum is still -1 and the maximum is still a +1. The midline and the period all stay the same. The only difference is that those 5 key points take a different place because you're multiplying by a negative. Okay, cosine has the same type of process for multiplying by those negatives or the whole or numbers in front. So let's take a look at those two examples, starting with negative cosine of x. So for negative cosine of x, lost my pen there, sorry about that. Let's get this graph set up. I've got my y-axis and my x-axis. Remember that my x-axis, we're not counting by ones, but we're counting by pi over 2, pi, 3 pi over 2, and 2 pi. My y values do still count by ones. And so if I'm multiplying cosine of x by a negative, then we're going to take a look at those inputs and outputs the same way we did with sine of x. So remember for cosine, when we find cosine of 0, that's here on the unit circle, but cosine is the x. So cosine of 0 is equal to 1. And so if I'm multiplying my output there by a negative, then I'm going to end up with a -1. And so the first point now is down at -1. Then for cosine of pi over 2, I go to pi over 2 on my unit circle. I look at the x part of the coordinate, so that's equal to 0. If I multiply that by a negative, -0 is still just 0. So I have the point at pi over 2, 0. The next one is cosine of pi. Cosine of pi is equal to -1. And so if I'm multiplying that by a negative, then a negative times a negative gives me a +1. For cosine of 3 pi over 2, I get 0, and if I multiply that by a negative, it's still 0. And then the final one, cosine of 2 pi, is equal to 1, and if I multiply that by a negative, then I get a -1. So you'll notice here that cosine still has the same shape that it did, but again, it's been flipped over the x-axis just like sine was. So when we're multiplying by a negative, it flips the graph over the x-axis. Remember that the original graph of cosine of x looked like this, where it started at its maximum, went down to its minimum. So now if you have negative cosine of x, it starts at its minimum. So really be on the lookout for that starting point. The starting point is a really good indication of what function you're working with. If it starts up at 1, then it's cosine. If it starts down at -1, it's negative cosine. And if it starts at 0, it's either sine or negative sine. And that would just determine whether it goes up or down from there. The last graph I wanted to show you is a graph of 2.5 cosine of x. So this is going to have a similar approach to the 3 times sine of x. Don't freak out because there's a decimal here. We can still work with this like normal. So our x values still count by pi over 2. You'll get really good at this the more you do it, I promise. And the y values still count by 1. And so we're going to take the same approach here as we did with sine of x. So we're going to start with cosine of 0. Cosine of 0 is equal to 1. But for this function here, we're multiplying cosine by 2.5. So 2.5 times 1 is equal to 2.5. So now my maximum is up here at 2.5 instead of the maximum being at 1. For cosine of pi over 2, it's equal to 0. And when I multiply 0 by 2.5, it's still equal to 0. So I'm still going to cross the midline at that at pi over 2. The next one is cosine of pi, which is equal to -1. And when I multiply negative 1 by 2.5, I get negative 2.5. So that's going to move my minimum down here to negative 2.5. Cosine of 3 pi over 2 is equal to 0. And if I multiply 0 by 2.5, I'm still going to get 0. And then finally, cosine of 2 pi is equal to 1. And if I multiply 1 by 2.5, then I get 2.5. And so that maximum up there would be up there at 2.5. And so you'll notice that the shape is the same. Forgive my sloppy lines there, but the shape is similar. It's just that it's been stretched out to be taller. And just like with cosine or with sine, when I multiply by that number in the front there, that changes my range because now my minimum value is at negative 2.5 and my maximum value is at positive 2.5. So now my range goes from negative 2.5 to 2.5. So hopefully those few extra examples were helpful for you. Please feel free to reach out if you need more help on graphing. Remember to use some of those graphing utilities to help you and really just get familiar with those pi values on the x-axis. That's really the biggest change that we're seeing here. So best of luck. Let me know if you need anything.